Electrochemistry is a branch of chemistry where we learn the conversion of electrical energy into chemical energy and chemical energy into electrical energy. Chemical energy into electrical energy means, for example, your mobiles you can take. Your mobiles are having batteries. On that batteries you can see lithium ion battery, it will be written. So there the chemical energy is converted into electrical energy. And sometimes electrical energy is used to get the chemical products. You take any industry, the industries are run by the electrical supply. The electricity supply is generally used there. And if you are preparing any compound, for example, if you are preparing sodium hydroxide, you prepare from sodium chloride electrolysis, breaking by using electricity, electrolysis. So here we are using electrical energy to convert that into chemical energy. Chemical energy into electrical energy and electrical energy into chemical energy. Both these are discussed under electrochemistry category. First one, Ohm's law. Important terms we'll discuss now. In that, the first one is Ohm's law. According to Ohm's law, the current is given here by I. The current flowing through a conductor at a given temperature. Given temperature means temperature must be constant. Is proportional to the potential difference. Is proportional to the potential difference and inversely proportional to resistance. It is directly proportional to potential difference and inversely proportional to resistance. So I is directly proportional to V. I is inversely proportional to R. Or you can say V is equals to IR. Okay. V is potential difference. Potential difference. I is current. R is resistance. The law is very simple. I is directly proportional to V, inversely proportional to R. Current directly proportional to potential difference, inversely proportional to resistance. Otherwise, simply you can remember V is equals to IR. The next term is resistance. Resistance is R. R is the opposition to the flow of current. Whatever the flow is there, current flow, to that flow, whatever the opposition is coming, that you can call resistance. Resistance means you can know that even English meaning also resistance means stopping. So it is the opposition to the flow of current offered by the electrolytic solution. Whatever the flow is there, the flow resistance we can call it as, the obstacles in that flow is you can call it as resistance. It is given the units of ohm. Okay, now ohm units. So, for example, if this is the flow, whatever the obstacles you are getting here, the obstacles in the flow you can call them as resistance. Resistance is the obstacles in the flow of current. Units ohm. Next is conductance. Conductance is given by G. G is reciprocal of resistance. G is equals to 1 by R. We were saying resistance is obstacles in the flow, obstacles in the conductance, and now you are saying conductance is reciprocal of the resistance. So G is equals to 1 by R. Our units you can say ohm inverse, or you can simply say mho, MHO, reverse, MHO is mho. Ohm inverse or mho or ohm inverse you can write like this. Resistance is R, conductance is G. Resistance of a particular electrolytic solution, R is directly proportional to A, L, and inversely proportional to A. Directly proportional to L and inversely proportional to A. What is L? L is the distance between the two electrodes. If, for example, these two are the electrodes, this distance is, if these are the two electrodes, this distance is L, and area of cross section you can say as A. Resistance offered by an electrolytic solution directly proportional to length and inversely proportional to area of cross section. R is proportional to L, R is proportional to 1 by A. So R is proportional to, you can say, L by A. R is proportional to L by A, or you can say R is proportional to G star. In place of L by A, you can call G star. L by A is only called cell constant. It is given by G star. L by A, length by area, is also called cell constant, which is known as G star. R is equals to, when the proportional mark is removed, rho into L by A. Or R is equals to rho into G star. Where rho is known as, this is resistance and this is specific resistance. Specific resistance. Or you can say resistivity. Resistivity or specific resistance you can call. So once again we'll come from the starting. Resistance is directly proportional to length between the two electrodes or distance between the two electrodes, and inversely proportional to area of cross section. So R is proportional to L by A. L by A is also called G star, cell constant. So R is equal to rho into L by A, or R is equal to rho into G star, where rho is specific resistance or resistivity. G is equals to 1 by R. Conductance is equals to reciprocal of resistance. But we know that R is equals to rho into L by A. Just now we have written this. If you are writing here, G is equals to 1 by R. In place of R I am writing rho into 1 by L by A. This you can write G is equals to 1 by rho is called as K. Small k I have written. Okay, now actually K, kappa. This is kappa into 1 by L by A, or 1 by, I can write L by A place, I can write G star also. So kappa K is equals to G into G star. Kappa is equals to G into G star, where K is, G is conductance, G is conductance, K is specific conductance. Specific conductance, or you can say conductivity. Kappa K is conductivity, you can say G into G star. Okay, so the units are also important. We will write all the units one by one now. G is equals to 1 by R. Conductance is equals to reciprocal of the resistance. G is equals to 1 by R. But R is equal to rho into L by A. Just now we have written. So G is equals to, in place of R I am writing 1 by rho into 1 by L by A. So L by A place we can write G star. So G star I am bringing here. 1 by rho. 1 by rho is known as K. Rho is resistivity, or is a specific resistance. Reciprocal of specific resistance, or reciprocal of resistivity, is nothing but conductivity or specific conductance. That you are writing here, K is equals to G into G star. R is resistance. Resistance units are ohm. Resistance units are ohm. G is 1 by R. Okay, now reciprocal of the resistance. So its units are ohm inverse or mho. Okay, now ohm you can write like this. So ohm inverse or mho for the G. That is conductance. Resistance is equals to resistivity into L by A, or resistivity is equals to R into A by L. R units are ohm. A units are centimeter square. Its units are centimeter. So rho units will be ohm into centimeter or ohm meter. Ohm into centimeter or ohm meter. Then kappa, conductivity. Conductivity is equals to 1 by rho. If rho is equals to ohm centimeter, 1 by rho units will be per ohm per centimeter, or is a per ohm per meter, per ohm per meter. G star is the cell constant. Cell constant is equals to L by A. L units are centimeter length. A is area, centimeter square. So centimeter inverse, or you can say meter inverse. Very important units. two more important definitions. One is molar conductance, second is equivalent conductance. Molar conductance and equivalent conductance both are given by lambda only. Okay, now this is lambda, this is also lambda. Lambda m when you are writing, that is molar conductance. Lambda eq when you are writing, that is equivalent conductance. See the formula? Lambda m is equals to kappa k into 1000 by molarity. Here lambda equivalent is equals to, equivalent conductance is equals to k into 1000 by normality. Then what is the difference between them? Molarity and normality. So molar conductance is the conductance power of all the ions produced by 1 molar solution. When you are taking 1 molar solution, whatever the conductance you are getting from that, all the ions produced by 1 molar solution is molar conductance. It is the conductance produced by 1 normal solution. Okay, now if normality is equals to 1, then k is nothing but lambda eq. Okay, so lambda eq is equals to k into 1000 by normality. If normality is 1, and 1000 is a conversion factor type, so lambda eq will become k. That means the conductivity only will become molar conductance or equivalent conductance. Molar conductance or equivalent conductance are nothing but the conductance produced by 1 molar solution here, 1 normal solution here. Lambda m is equals to k into 1000 by molarity. Lambda eq is equals to k into 1000 by normality. So you can check the units also here. Molar conductance lambda m, equivalent conductance lambda eq. Lambda m is equals to k into 1000 by molarity. It is k into 1000 by normality. K units are per ohm per centimeter, 1000 centimeter cube, and molarity per mole. Okay, now. So when you are taking here 1000, that is nothing but in 1 liter solution you are taking, so that is centimeter cube. So this you can write per ohm centimeter square per mole. In place of this you can write Siemens centimeter square per mole. This is for molar conductance. And what about the equivalent conductance? Lambda eq per ohm centimeter inverse centimeter cube equivalent. You see, this is equivalent. So in place of mole you have equivalent, rest everything is same. So the units are important. Okay, now just now we have written 5 different units: conductance, resistance, specific conductance, specific resistance, cell constant. 5 plus 1 more. Okay, now total 7 definitions we were discussing. Along with this we were having one Ohm's law. Total 8 definitions. Every line is important here. Effect of concentration on K, lambda m, lambda eq. That means conductivity, molar conductance and equivalent conductance. Very simple. Kappa K directly proportional to concentration. When the concentration increases, if you are increasing the concentration, whenever the concentration increases, very simple logic, number of ions per unit volume increases. Okay, concentration increases means, for example, let us see, this is 1 molar solution, but 1 molar solution means 1 mole compound in 1 liter solution. If you are making 2 molar solution, whatever the number of ions are there, now whatever the number of particles are there, that particles number will be increased double. 2 molar to 3 molar, 3 molar to 4 molar. When you are increasing, obviously the number of particles in the particular area increases. That's why the conductance, specific conductance also increases. K directly proportional to concentration. When concentration increases, K also increases. You can say as concentration increases, number of ions per unit volume increases. That's why K value increases. But interestingly and surprisingly, remaining 2, lambda m and lambda eq, both inversely proportional to concentration. That means if you are increasing the concentration here, lambda m and lambda eq both will be decreasing. Okay, now here the reason is again interesting. Because of ionic mobility decrease. When you are increasing the concentration, number of ions will be more, and when number of ions are more, the ionic mobility will be less due to the decrease in ionic mobility because of the increase in interionic attractions. When the concentration increases, ions will be very close, so interionic attractions will be more. Because of those interionic attractions more, this lambda m and lambda eq, molar conductance and equivalent conductance, both are going to decrease along with this concentration. K directly proportional to concentration, both these inversely proportional to concentration. Very special points. Okay, conductance, specific conductance or conductivity kappa directly proportional to concentration. As you are increasing the concentration, it will increase. And these two inversely proportional to concentration. If you increase the concentration, the number of ions will be increasing. When the number of ions increases, more number of ions are there. Like our India population is more, density is more, we can't move here and there, like in cinema theaters, melas and all. So the movement of us will be less. Okay, now more are there, more persons are, more people are present there, but we can't move here and there. When the ions move, then only the conductivity will come. Okay, now so the conductivity is decreasing along with the increase in the concentration. This you can say by the formula also. Lambda m or lambda is equals to k into 1000 by concentration. So concentration increases means it will be decreasing. One very important point it is.